Hey there, and welcome to the channel. I'm Brian, and in today's video, we're going to be working on this board right here. What is this board? Well, let me get out of the way. There we go. So this board right here is an S17Pro hash board. It's got 48 chips on it, and it's something I've never worked on before, other than the fact that I've got about a box of 30 of these that I've been stripping for the chips. But I've not actually worked on one of these to make it work. So what are we doing today? Well, it's really simple. We're going to upgrade the heatsink. We're going to investigate why this board is reporting 0 ASICs when it's in the miner. So let's get to it. It's an S17 Pro. Now, if you take a look down here at the board, I've got it on my bench. This is a little bit different. Most importantly, it doesn't have as many chips. What you've got are 12 rows or 12 domains with 4 chips each versus, so that's 48 chips versus the 65 chips and 13 domains in an S17 Plus. So that's a little bit different. Also, as you'll see in a little while, the nice signal points aren't as well mapped out. This is a much older board. But the reason I pulled this board out of the miner is because it's showing 0 ASICs. But here's the problem. Let me put power on it. Okay, and I just happen to, I can look here visually and I can tell that closest to the plug is negative and this is positive. Cool. Let's flip over to our tester mode. We can see that. And if I hit the start button, well, 48 chips. But Brian, you said it was a 0 ASIC. Yeah, that's the problem. When I do this, when I put it in the miner, it tells me it's 48 or it's 0 ASICs. And when I put it on the bench, it tells me all the temperature sensors and everything work. Okay, so what I've been wanting to do to this particular miner and these hash boards anyway is convert them over, take these old archaic terrible heat sinks that fall off and break in shipping and everything else, and I'm going to change them over to these heat sinks just like very similar to what I use on the S17 Plus. So that's what we're going to do today. We're going to strip all this, and in the process, maybe I can find some solder balls that's causing the problem, because I think that's what it is. These boards were notorious for solder balls. So let's dive into it. First things first, I need to turn on my air station. There we go. I've got my air station set pretty much the same thing I always use, 425 and 80 on the airspeed. I do have my handy dandy bent tip or angled tip. And all I'm going to do is just go one row at a time, one domain. I'm going to start with number 1, and I'm going to work my way this way. Just strip the chips. That's all it is. Let's get into it. All right, so the board is stripped and I've got heat sinks all over the place. If you, when you're taking off heat sinks, if you have problems with the chip coming off with the heat sink, that's probably because you're getting the heat sink too hot. And you'll notice that I did that little bitty twist, right? I had my tweezers just at an angle, and I just had a light bit of pressure. And as soon as the solder would come loose, you'd see the heat sink turn. And so you might want to try that, because once I started using that technique, I don't have chips coming off the board with the heat sink anymore, unless somebody did a repair and used high temperature lead-free solder. All right, so what's the next step? Well, the next step is I'm going to clean all the tops of the chips. I've zoomed the camera in just a little bit. I'm going to be using my soldering iron with my large tip. Let's see, I can put it under there. So that's my largest wedge type tip that I've got. And I think it's called a bevel. Not for sure what it's called. It's the round tip that I like to use. And then I got my soldering desolder wick. I'm using my ceramic tweezers. That way the heat doesn't get sucked off into the tweezers. And these are reverse tweezers, very handy. And then I'm going to use my MG Chemicals flux paste 8341. Okay. All right, and you just go and just clean off the top of every single chip, right? We're going to just go through all 48 chips. Let's get to it. Okay, so that's it, right? Just cleaned off all of the tops of the chips, and I just kind of kept the process moving. I tried not to stay on any single chip too long. One thing to be careful about when you're doing that is that you don't get the chip so hot that the solder starts to melt on the little bitty the legs, right? Because then you're going to have a problem. You're probably going to bake the chip at that point, especially when I'm running my iron at 395. So that's it. Next step, let's get this thing into an alcohol bath. Let me turn off my exhaust fan. If you don't have your exhaust fan running for that part, it's kind of smelly. Okay, so let me get this into the alcohol bath and we'll get all this cleaned up and then we can look at it under a microscope. Okay, so that's it. We've got it. I've got it cleaned up, and you just saw I used my bent toothbrush, which just did that with my heat gun. Did that with a bent toothbrush and some alcohol. And since the alcohol wasn't enough, I added some more alcohol. It's 99% IPA. So now let's get under the microscope, and I'm just going to do a real simple check of everything. Make sure that I don't see any solder balls. If I do, I'll clean them up. If I see any kind of damage or anything, I'll clean that up. Really what I'm doing is I'm just waiting. I'm doing this while I'm waiting on all the alcohol to evaporate and get off the board before I put it into testing, because we're kind of close to the next step. All right, so I've got the microscope zoomed in, and this is chip 1, and we're just going to run through. We'll watch it on the big screen. So hopefully that doesn't move my microscope around so much, but we're just going to move through every chip, and I'm just going to look for missing resistors, solder balls on the legs, anything I can see that would cause an issue. Now, I'm not as familiar with this board as I am. Hold on a second. Let's move. There we go. Ooh. I'm not as familiar with this board as I am, say, the S17 Plus. It's a new board to me. So I don't know. I'm not used to all the resistors being where they need to be, and I don't have my cheat sheet telling me where a pad can be that doesn't have a resistor. So I just have to compare to the 30 plus scrap boards that I bought of S17Pro boards. Okay, that was pretty clean board. There was a little bit of debris you saw me take off, but I didn't see any solder balls. All the solder connections look good. A lot of the S17 boards I've been harvesting for the chips in the big board lot that I purchased from a guy in Florida. Well, all of those boards had little bitty solder balls in between the legs on the chips. These don't. So I was expecting at least find one. Let's get this thing back on the tester now that I've taken it all apart, and let's just check it, because the next step is to put the heatsink nuts on there. So let's do a quick test. I love taking my tests, so let's do that real quick. Okay, so here we go. We got the board plugged in. There we go. You can see that. Good. Let's hit the go button, and let's see what we get. Oh, we get 0 chips. Yay me. Okay, well, this is the fun part, because I don't know these off the top of my head. So what I do know, let me pull it up. We know that it doesn't matter if you look at it doesn't matter if you look at the left chip or the right chip, because those are just 2 different modes, whether or not it runs in mode 1 or mode 0. And the board tells you which domains are 0 and which ones are 1. But if we look down, the RI signal, which is going to be what we're going to short to, so the RI signal is pin 10, and so that's 10 down from the left corner of the chip, and it comes out or goes in, depending on which direction you're thinking of, mode 1 or mode 0. It goes in and out on pin 27 of the chip, which will be the 6th one down. There we go, right? So we know it's going to go the 10th pin down on the left side, and the 6th pin down on the right side. So that's how we're going to figure this out. And we might use a microscope. All right, let me get that chip set out of the way. Yeah, we're going to do this under a microscope. So. Well, how about that? I've already got it set up. Okay, so let me find where it is. Okay, so what we've got there, that's going to be, let me get my jumper. Got my handy dandy jumper right there. You can see it. Cool. All right, and so pin. Let's get off of the dome. There you go. All right, so pin number 1. Here we go. So pin number 1 is here, and the flow. The flow is going to be coming in on the top. No, I'm sorry. The flow is going to be coming in on the bottom and going out on the top. But that doesn't really matter, other than which pin do we want? We want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? There we go. Okay, so we want that pin, and then this is the all right, so there's the RO there, and we should be able to short to here. Let's see how that works out. Hey, 18 chips. Yeehaw. Now, I'm going to cheat. I say cheat. I'm going to move over to the next domain that's in the same mode. There's 26. So I'm just hopping over every other domain. There's 34. Oop. There's 42. Okay, so I know we've got it all the way to 42, which is right there. You look down the bottom. All right, so we're going to come up here to 45. I'm going to jump. I'm going to go ahead and follow all the way through. I'm going to go to 45. So I'm going to find the jumps here, right? I'm going to find what those pins are right there. Look at my microscope. Now this is the leaving side of the chip, so remember that's 6 down from the top of the chip, because there's pin 1. So 1, 2, 3, 4, 5, 6. There's the test point. Okay, so that's the test point we want, and we're going to short to that right there. Okay. Nothing. I jump back 1. I got 43. So I got nothing on that. Okay, we need to check something real quick. Let's get, let me see. What's the easiest way to show this to you? Okay, so I'm going to get over here. I'm going to grab my meter, put it in voltage range. I need to verify that we got 1.8 and 0.8. So here's the really weird thing. I just kind of stumbled all over myself because I'm looking, and this is the oops, it's off screen. This is the positive rail. This is the little rectangle, and this is the big rectangle. So technically, if I'm going to measure my voltages, I need to go here. So this board's just laid out completely different for what I'm used to. All right, so I go ahead and I get to here. So I've got my negative probe on the essentially negative of this domain. I go to there, I got 1.8 volts. I'm going to jump over to here, and I'll hop over here, and I should be able to get test 0.8. Okay, so I got all the stuff I need in this domain. Voltage is good. So we need to figure out how to jump that chip. Let's go under microscope straight for a second. All right, remember when you're doing jumps on the domain, or from the domains itself, you need to grab the voltage to short it from the next side over. Okay, so I'm going to short that one over to the 1.8 right there. So top ball to here. All right, that's the plan. Okay, so I got my jump there. And I'm looking in my microscope, and okay, I got 44. Cool. That means that's good. Ah, I got 48. Magic! All right. Magic. Let me think about this for a second. So I've got myself set up here, I think. Let's see. I thought I had myself set up. Okay. So that's chip 45. Now what I'm going to try to do, I'm going to try to measure it. So you see the voltage readings there. I'm going to try. Okay, 1.78. This is RO right here. That's 1.7. Okay, what is that one? One, two, three, four. Okay, so that is the fourth one down. And if I pop up my chip, and we are in mode 1. So look on the left side there. Fourth one down on the right, that's VO. So that's what we'd expect. Okay, let's check the return, which is going to be the next one over. So that would be right here, would be the return. Yeah, it's good. And that is good. This should actually have, there we go. Okay, so we're missing, okay, so that is, yeah, that's right. Yep. And 1.7, 1.7, 1.7, and 0-ish. Cool. All right, well, the fun part is we have 0 chips again. All right, the board's getting hot. I'm gonna let it rest for a little bit. All right, let's go to diode mode. Okay, now we can test. Let's see, so this should be, oh, that's continuity mode. Let me go to diode mode. Okay, so if I remember correctly, that's high. That's right. That's right. That's high. That's high. Okay, so that makes, well, at least on a S17, those values are high. Let's get a comparison. So we'll do it the next one down, right? Oh wow, 1.37. So things are a little different here. 0.3. That's normal. 1.39. 1.37. Okay, so let's check another one. Well, that is very high. Jump over 2 domains here. And that way we're testing the same direction, same pins. Okay, and 2 domains over from there. All right, so it seems like if I were to look at all of them, it seems like the normal is 1.3 versus 1.2. Let's go back over here to this guy right here. Okay, 1.3, 1.1. So that's actually low compared to what everybody else is. Okay. Right now, I should be able to come over here. And I just got to get 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so. Yep. 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 Okay. Okay. All right. So chasing through that, the diode values look right. Let's check this one down here just as a reference. 3, 4, 5, 6, 7, 8. So I can test 1, 2, 3, 4, 5, 6, 7, 8. Yep. Okay. There's your RO. Okay, so all right, so it looks like we probably have a problem right around chips 44 to 45. That's what it seems to be, and it's only when it's cooled, because once the board heats up, that doesn't happen. So if I can remember this, okay, there's 43. I'm not able to jump past 43. Get that, oop, there it was. There's 43. I believe that is the right voltage leg right there. Yeah, so actually, I think the problem is 44. Even though it's hot, it's not passing. So I'm going to go ahead and replace chip 44 while I've got the board apart. Okay, we're back. Board's cooled off. Chip 44. Let me go ahead and label it so I know that that's the chip I replaced. Let's see, now that the board's had a chance to cool off, let's see if it shows 48 chips. Bingo. 48 chips. That's what I wanted. Jumping chips when you suddenly have 0 ASICs, I just find that to be the fastest way to debug things. Let's check our temperature. Cool. Looks like we got all of our temps running. Excellent, excellent. So let's get back on track now. Then let's finish installing the heat sinks, right? Because that's what I'm actually doing today, putting heat sinks on. All right, I don't mind telling you, this is the first time I've ever done an S17Pro heatsink kit. It should work pretty much the same way as the kits I use on the S17 Plus, but hey, it's something new. Nothing like doing it right there on camera for the first time. So I've got 2 heat sinks because this board works, this hash board with 48. It works like that, right? So you've got your rows there, and then you've got another set of rows here. So they use quite a few screws, and you'll notice this looks a lot like the NBTC that I pulled off of that one hash board. What was it, 102, I think? I had to check the playlist. The nice thing is, if you look, the slots are kind of, they're slotted, right? So there's a wiggle room. This should be pretty easy, and this works with washers and springs and these special screws that if you try to buy these off of AliExpress, which is the only place I found them, they're like $10 for 5. They're crazy expensive. Okay, good news, I don't need to buy any because I've got plenty. Okay, I want to do a halfway point check. We've got I've got half the nuts put on. So, great time to do a halfway check. Oh dear. We have something wrong. All right, let's just test that. Okay, it was the miner, or I'm sorry, the team miner, Antminer tester got screwed up. Whew. I won't lie. It's like, how the heck do I troubleshoot this thing? All right, so good. We've got all the chips working. Let's test our temperature. Okay. Temperature's all good. Okay. So there we go. It's all the nuts are mounted. I'll admit I had a couple of challenges. This one right here popped off twice. This one popped off once. And when I was doing this one, I had a problem with the solder on this chip, and so afterwards I had to reflow the solder. So let's go ahead now and test it. Let's see where we are. $48 chips, very good. Let's do the temperature test. Get all the values. Everything looks good. Super. Okay, let me do a little YouTube magic, and I will get the plates mounted, and we'll test it one last time before I put it back in the miner. I won't lie. That is it's a beautiful thing right there. We are up and running. The board is fixed with the new heat sinks. Now it is interesting that the new heat sinks don't work quite as well as the old heat sinks. The blocks tend to run warmer. I may need to just run some different heat sink grease, but for now it's running. Let's go ahead and look at the chips themselves. All right, so we do have a bank of chips that are not happy. It's not any of the chips that I replaced. Or I only replaced one chip, right? 44. So 44 looks good. And we got some weakness in, looks like in chain 1. Whenever I upgrade that board to one of the new heat sinks, maybe I'll go ahead and fix those chips as well. All right, so that did it. We've got all the boards in my farm that are in miners are working. If the Lord's willing and the creek don't rise, tomorrow I'll start working on hash boards that I bought specifically to build new miners, or new to me miners. So that's really exciting. I'm going to finally move from repairing and keeping my farm working to actually adding some chassis and some miners to the farm and expanding the hash rate. That is awesome. Thanks so much for watching. If you haven't already, be sure to click that subscribe button, give me a like, and hit that notification bell. And if you've got some comments, I would love to hear your comments. Tell me, was that too much detail? Was that not enough? Did I skip over? This was a long thing. Just fixing one chip, but the upgrade on the heatsink, I'm still working on that. Getting those nuts anchored, that's still something I'm still practicing to get better at. But again, thank you so much for watching, and I hope something was useful in today's content for you. Have a great day, and I'll see you soon.